Let's resume chapter 8. In the previous videos, we went through the estimation theory in 8.1 and 8.2. There, the key concept, the key destination was the confidence intervals. Now let's begin the next topic, hypothesis testing, which will be covered by the next three sections, 8.3, 4, and 5. In 8.3, we talk about some jargons, some meaning of the hypothesis and hypothesis testing and the nature. And then we talk about the technical details in 8.4 and in 8.5. 8.4 and 5 are kind of parallel. We talk about one method in 8.4 and the second method in 8.5. According to our textbook authors, the second method, the classical approach of 8.5, is an optional topic. But I disagree. I encountered a lot of instances where the classical approach of 8.5 is superior. Of course, there are some cases where 8.4 method is easier to understand. In any case, we're going to cover both. They're both required, nothing is optional, so don't be fooled by this optional tag. If at all, I'm going to put a little bit more emphasis on 8.5 rather than 8.4 to tell the truth. The reason will be answered in the next chapter, chapter 9. Okay, let's begin. The nature of hypothesis testing, and this is the way our textbook authors explain these terms. Hypothesis, a statement that something is true. Of course, whether it is true or not has to be tested, and that's what we call hypothesis testing, roughly speaking, of course. But then again, this is a math course, so we have to do far better than that. Just testing, no, that's not going to cut it. This is what we usually do. Set of two competing hypotheses. One, null hypothesis, H0, and the other, alternative hypothesis, HA. The null hypothesis is the kind of status quo. The starting point, there's no difference, those kind of things. When the testing is inconclusive, then we have to go back to the null hypothesis. Alternative hypothesis, on the other hand, is a change, the new result. So we take alternative hypothesis if and only if there is sufficient evidence that supports alternative hypothesis and against null hypothesis. Of course, exactly how much, that's something we'll have to discuss later on. Here's an analogy. If you enjoy some sporting event and then if you see a referee going to the instant replay booth and then watching the replay and then making the call, in that case, a null hypothesis is the original call made on spot in play in the field. And if there is sufficient evidence to overturn it, then of course we go to alternative hypothesis. But if the replay is inconclusive, then we just go back to the null hypothesis. Inconclusive or not sufficient evidence, then we just go back to the original call. Another example, in a criminal justice system, in a courtroom, the null hypothesis is not guilty. The guilty is, of course, the alternative hypothesis, and we go to the guilty verdict if and only if there is really indisputable or what they called evidence beyond reasonable doubt. Yes, that's the term they use in criminal justice system, I think. Only then we take the alternative hypothesis and deliver the guilty verdict. Otherwise, just go back to null. It's not like which one is more likely or less. So, in normal circumstance, and the probabilities and everything overwhelmingly favors the null hypothesis, the status quo. Of course, this is a math course, so indisputable evidence or beyond reasonable doubt, those kind of things will not cut. We have to quantify all those in numbers, and that's what we call significance level or level of significance. That's going to be discussed in the next section, by the way. In any case, I think that was sufficient for introduction, so let's go to my notebook. Let's have a little bit further discussion here. Here are some structures of hypothesis testing, and let's talk about null hypothesis again a little bit, because I forgot about one important aspect. Status quo, we talked about it. Default, no difference, we talked about. But another thing, past. Traditional thing, we just take whatever we do, go back there, that's null hypothesis. Alternative hypothesis, there's some difference and something new, that's going to be alternative hypothesis. Most of the time, not absolute of course. Here are some mathematical structures of null and alternative hypothesis. And null is same as before. On the other hand, alternative hypothesis is, come on. Okay, successfully highlighted. Mu is greater than the traditional value, but not just greater, but significantly bigger. Or on the other case, significantly less. In some cases, rather rare, but in some cases, the alternative may be just simply different from the traditional value. In any case, null hypothesis remains the same as before, status quo, the past result. Okay, there may be some mathematical purist sitting here watching this video. For those people, let me be a little bit more precise. Mu is greater than or equal to the traditional value mu naught, or actually significantly bigger than that. So the alternative hypothesis which complements it will be actually not just equal or approximately equal, but less than or equal approximately. And in this case, if mu is significantly less, then greater than or equal approximately, those kind of things. But those are for purists only. Most of the time, this kind of thing is sufficient. About the same is null, and alternative hypothesis most of the time significantly bigger or significantly smaller. Okay, let's go to an example. I think we have sufficient time to do at least one example, maybe two. Here's an example. The drying time of a type of a paint under specified test conditions is known to be normally distributed with a mean value of 75 minutes. So this is mean, so there's a candidate of mu naught. And the standard deviation is 9 minutes. Okay, that's specifically assessed in that standard deviation, so that's not going to appear in hypothesis setting up. I mean, here they're all about mu's, nothing about sigma, so that's going to be a dead information as far as this problem is concerned. A group of chemists proposed a new additive. Here's a keyword, new additive, which means whatever comes afterward must be something new. So that's going to be alternative hypothesis, not null. All right, let's go back. In a lab test, the researchers obtained a mean drying time of 72.3 minutes in 25 observations. Set up appropriate hypothesis. Most of the time, it's going to be either this or that. And rarely, but in some cases, we have this. Okay, what is mu naught? That's pretty obvious. Traditional value, past value, which was explicitly given. This one. How about the other one, 72.3 minutes? And that was bound to the sample study, the lab test, which was done with 25 observation. So this value, 72.3, is associated to the sample test, not the traditional value. So mu naught has to be 75. Well, let me write down everything here. So which is it, 75 or 72.3? Well, it should be 75, the past result. 72.3 is a new one. Okay, what about alternative hypothesis? Is alternative hypothesis mu equal to approximately 72.3? Kind of like this. Is that it? The answer is no. Go back to these mathematical structures. The alternative hypothesis do not come with equality or approximate equality, either significantly bigger or significantly smaller or significantly different. Not approximately equal or something. Equality or approximate equality is going to be used for null hypothesis, not alternative. So this is no good. This is not it. And also, let's go back to this mathematical structure. It's about mu is greater than or equal to mu naught, and mu is less than or equal to mu naught. So they're both about mu naught value, 75.0. So which one is it? Is greater than 75 or is it less than 75? That question will be answered by this new result, 72.3. So if you're a researcher, what would you suggest? 72.3 is certainly less than 75, so yeah, we're going to do less than 75. Of course, there's another evidence here. A group of chemists proposed a new additive design to decrease the drying time here. So there's another indication that the null hypothesis has to be less than 75, or to tell the truth, a bit more precisely speaking, significantly less than 75. If you use a normal picture, you have this kind of visualization. You have a normal distribution around 75 minutes. The null, and we have normal picture around 75 here, and 72.3 is less than that, and the question is whether it is close enough to 75 or sufficiently far away from 75. If it is close enough, then close enough to the null, then you're going to select null hypothesis and reject alternative hypothesis. If it is far away, sufficiently far away, then we're going to accept alternative hypothesis and reject null hypothesis. That's something we'll have to discuss a bit later. But at this moment, let us concentrate upon just setting up appropriate hypotheses. So null and alternative hypothesis. Oh, by the way, why did I close everything? This is null and that's alternative. Let's see, do we have enough time for the next problem? I do not think so. So let's talk about examples 2.4 and 2.5 in the next segment of video.